All right, calculus remotes. Here are some notes that we have done in class the last few days. First one here, so let's call this section 1.3 notes continued. And at the end, I have a little health reminder of the other videos to watch as well that might already be on Google Classroom or Yak Math Videos calculus playlist. So the first one is example 1, a table of values for f is given. Give the tables for the following functions. So first off, write this. This is the original table that we will keep going back to. X and Y, -3, -1, 1, and 3. For X, Y, 11, 5, -1, and -7. Y equals f of x plus 2. All right, so what's going on? This is a vertical shift, VS, vertical shift up 2. Vertically, it's the Y, so this graph is just moving up 2. With the Y's, the X's are staying the same. So I literally write the same 4 X values. All the Y values go up 2, so I add 2 to all the Y values. And it's as easy as that for that first one. Second one, B, that's going to be a pain if this happens again. Second one, I should learn the lesson there, I guess. On B, this time we have a horizontal shift. It's on the inside here with X. It's a horizontal something, and it's a shift to the right. Y to the right. Set X minus 3 equal to those original X values. Set X minus 3 equal to -3, X minus 3 equal to -1, X minus 3 equal to 1, and X minus 3 equal to 3. See what you need for X to kind of get you back there. So 0, 2, 4, and 6. We're really adding 3. It's a horizontal shift, 3 to the right. The graph is moving 3 to the right. The Y values stay the same. The X values, we add 3 to all of them because it's shifting to the right. Now C, Y is f of x minus 4. This is a vertical shift, VS, down 4. So all the Y values go down by 4. The X values stay the same. That's why we have that table. The next one is like B. I have a horizontal shift, this time 1 to the left. Again, set X minus, or X plus 1 equal to -3, X plus 1 equal to -1, X plus 1 equal to 1, and X plus 1 equal to 2. The Y values stay the same. All right, on E here, again, we have a horizontal something. It works opposite. So if you see 3x, you would think, oh, all the x values are getting multiplied by 3. I'm stretching the graph out. But no, what do you got to do to 3x to get it back to x? Just like what do you got to do to x plus 1 to get it back to x? That's why we subtracted 1 and not added 1. I divide all my x's by 3. This is actually a horizontal shrink by a factor of 3. So I set 3x equal to all of my original x values that I gave you at the beginning. -3, -1, 1, and 3. And I divide them all by 3. -1, -1 third, 1 third, and 1. Nothing is happening to the y values. F is a combo here. What am I doing on F? Let me practice some things here. First off, I have a horizontal stretch. Again, 1/2. What's the opposite of dividing by 2? Multiplying by 2. You know, what I got to multiply 1/2 x by to get back to x? I would have to double it. So I have a horizontal stretch by a factor of 2, and I have a vertical shift down 4. So all the y values go down, down 5. All the y values go down 5. Subtract 5 from all the original y values. And double all the original x values. The graph is stretching while it's going down 5 as well. 2 different shifts. All right, pause this whenever you need to. This is an interesting one. Example 2. Use the table to evaluate each expression. So you have x. What 1 and 3 and 6 mean? When you plug 1 in for x and f of x, you get 3. When you plug 1 in for x and g of x, you get 6. So f of 1 is 3. G of 1 is 6. So look at that. F of G of 1. G of 1, all right, so G of 1 is 6. Now I need to figure out what F of 6 is. So F of 6 is 5. All right, G of 1 is 6, so I need to figure out what F of 6 is. F of 6 is 5, and that's my final answer. G of f of 1. All right, so f of 1 is 3. So I need to figure out what g of 3 is. G of 3 is 2. F of 1. F of 1 is 3. So what is f of 3? F of 3 is 4. Let's talk about this next one. G of 1. I'm sorry, G of 1. G of 1 is 6. So what's G of 6? G of 6 is 3. This is G of f of 3, so figure out what f of 3 is. F of 3 is 4. So what's G of 4? G of 4 is 1. F of G of 6. What's G of 6? G of 6 is 3. So what's f of 3? F of 3 is 4. All right, so that's a very good example. Let's talk about example 3 here. I've kind of done some of it. So find f of g of x, g of f of x, and g of x. If f of x is 3x squared minus 2x, and g of x is 11 minus 5x. Well, the first one, f of g of x, means f of what g of x is, 11 minus 5x. So I got to plug in 11 minus 5x there and there in f's equation. So 3 times 11 minus 5x, square it, minus 2 times 11 minus 5x. It's a lot of algebra, so result follows. Just take your time on a quiz and a test. So g of f of x would be g of what f of x is. So I'm plugging 3x squared minus 2x in for x right there. That's no big deal. 11, yeah, there it is. It's like, I was looking at the wrong one. So 11 minus 5 times what I'm plugging in for x. Distribute, write it in standard form. There we go. And finally, g of x means g of 11 minus 5x. I'm plugging 11 minus 5x in for x right there. So 11 minus 5 times 11 minus 5x. Distributes. There's my final answer. Number 4. Determine whether f is even, odd, or neither and show why. So f of negative x equals f of x. It's an even function. If f of negative x equals the opposite of f of x, it's odd. What does this mean? Negative x and x are opposite numbers. So if I plug in the opposite value of x, I call x 2. If I plug in a negative 2 and I get the same answer, equals, then they're even. If I plug in 2 and negative 2 and I get opposite answers, f of x is odd. So that's what you can do for me. So A here in black, f of x is 4x to the third minus 10x. What I did is I plugged 2 in for x, and then I plugged negative 2 in for x. So I'm going to want you to do something like that. You could choose 1 and negative 1, 3, or negative 3 as well. Now, if I plug 2 in for x, I get 12. If I plug negative 2 in for x, I get negative 12. 12 and negative 12 are opposite answers. Opposite answers means f of x is an odd function. All right, so get down that work, have that down. Pause this if you need to. So next one here, f of x equals 5x to the third minus 8x plus 2. The exponents are odd like the last one. You might be guessing odd, but this one has a constant. So plug in 2, plug in negative 2. Notice I get 26 and I get negative 22. Those are neither those are neither equal to each other, nor are they opposite. So this is neither. And here's why. It was looking like it was odd because they were opposite. But that vertical shift added 2 to both instead of adding 2 and subtracting 2, which would have kept them opposite. So because you have that plus 2, that constant, you cannot have an odd function. So an odd function has no constant there. All right, in this type. All right. the ones I'm going to give you. Look for the constant. Constant's going to make it a neither if you have it out of exponents. Now, does the constant affect an even function? Look at that. To the fourth and the second power, those are even. Plug 2 in for x. Plug negative 2 in for x. I get the same answer. So the same answer, that's better than equal. Because they are equal, or because you get the same answer, you have an even function. All right? The same answer, even function. Find f of g of h of x. If f of x is this, g of x is that, and h of x is 4x minus 3. F of g of h of x. We'll do g of h of x first. So g of h of x is g of 4x minus 3. That means you're plugging in 4x minus 3 in for x. Right there. So 3 times what you're plugging in for x plus 11. That is the square root of 12x plus 2. So that is what I'm now plugging in for x and f of x. So now I need to do f of the square root of 12x plus 2. So I have 2 times what I'm plugging in for x squared minus 7. That's what f of x tells me to do. When I square roots, what's in the square root falls out. I double it, and I subtract 7. That's a pretty nice one. These are all very similar to the homework set that's due on Friday by 9, and your quiz that's going to be on Friday. So I just made this video, calculus, difference quotient examples. I think it says chapter 1. I just made that video today. So please watch it. That is also for you, but this one is definitely for your remote kids. And this is Yak Math Video signing out.